Well, how do we spell SOHCAHTOA? SOHCAHTOA is the acronym that we're going to be using, and hopefully you used in geometry when you were taking geometry, section 8.1, 8.2, 8.3, 8.4. So you can go back to your notes just in case, just to have those notes in your locker or your closet or somewhere, okay? So, how do you spell that? SOH, SOHCAH, CAH, and then TOA, TOA. Okay? So if you look at your notes, the name of the section is trigonometric functions and acute angles. Yes. It's just sine. Sine is the opposite of the hypotenuse. Cosine is adjacent over the hypotenuse, and tangent is opposite over the adjacent. And also, from sine, from cosine, and from tangent, we have the inverse functions. And in this case is cosecant, which is the reciprocal of sine. Do you see how sine is opposite of the hypotenuse? Well, cosecant is going to be hypotenuse over opposite. Cosine is adjacent over the hypotenuse. Well, secant, which is abbreviated as SEC. The other one is CSC. So those are the abbreviations. Okay. So secant is the inverse trig function for cosine. Cosine is ka, AH, so this is going to be HA. So it's hypotenuse over the adjacent. Tangent is opposite over the adjacent, opposite of the adjacent. Well, cotangent is the reciprocal of that, is adjacent over the opposite. So it's just switched around. Okay? So hopefully you'll now remember SOHCAHTOA, sine, cosine, tangent. And now what we're adding to those three functions is the reciprocal functions, which is cosecant, secant, and cotangent. One way of remembering which goes with which one is, this is the way I remember. If it starts with an S, then it starts with a C on the inverse. If it starts with a C, cosine, then the reciprocal function starts with an S. So it's S, C, C, S. And then just tangent, cotangent. It has part of it on the word. Okay?
So SCCS?
Basically,
So
yes.
this, if we go to the SOHCAHTOA, it's going to sound like a show, cha, tao.
Basically. If you switch it around, right?
So,
Sho, sha, tao. Sounds interesting.
sounds Chinese.
Chinese, that is right. Okay, so for the first 6 trig ratios, if this triangle is given, what we do is, first of all, it's recommended that you label your triangle. Across from the angle given is what letter? O, because of the opposite side. Across on the right angle, all the time is the hypotenuse. And the side that is right next to the angle is the adjacent, okay? So when we get the 6 trig functions, let's use the abbreviations for those. It's going to be sine of theta equals, this is the opposite over the hypotenuse. So the opposite side is 12 over 15. And then just make sure you reduce to the lowest terms and don't leave radicals in the denominator. So 12 over 15, you can reduce it, and that would be what? 4 or 5. Cosine, COS of theta. Cosine is adjacent over hypotenuse. So adjacent, okay, 9 over 15. And then you reduce that ratio, and that would be 3/5.
Miss, are we gonna be able to write these formulas down?
What you can do is, as soon as you do something like this, just write on top SOHCAHTOA. That way you remember. But you're not going to be able to have it, no. You're not going to be able to have it on your formula chart either. So this is something that you need to make sure you remember from geometry. Yes. So tangent is opposite over the adjacent, and so the values for that is, they are what?
12.
And then you reduce 12 over 9, and that would be 4/3. Great. Okay, so then the inverse functions of those three,
Wait, it can be an improper?
yes, leave it as an improper. Don't change it into decimals, please. Just leave it as ratios, reduced ratios, even if they're improper fractions. Okay, so then what is the reciprocal function for sine?
Cosine.
Cosecant, which is the reciprocal of OH, so that's going to be HO. So I just get the ratio that I have for sine, and I just switch it around. Then for cosine, the reciprocal function is secant of theta. And secant of theta is a reciprocal of cosine, which is 5/3, right? So it's hypotenuse over adjacent, which is 5/3 when you reduce it.
Oh, you're just switching them?
You just switch them, that's all it is. And then it's cotangent, COT, of theta, the reciprocal of tangent, so it's A over O.
30/4.
That's right.
It's just a matter of memorizing them.
I think it's a matter of remembering Socator. Right. So now you try number 2.
Miss, can you spell them again?
Socator. SOHCAHTOA. Hey guys. Okay, this is David's Zavala, right, David? This is David's problem. First of all, you label your triangle. And for sine, did you get 6 square root of 2 over 2?
Yes.
Yes? 6 square root of 2 over 2.
I got that.
Okay? Because the opposite is 6 square root of 2, and the hypotenuse is 11. So 6 square root of 2 over 2. So far, so good?
Over 11.
I'm sorry, over 11.
Yeah.
So it's 6 square root of 2 over 11. Cosine is 7 over 11.
Yes.
Tangent is 6 square root of 2 over 7. Then when you get the reciprocal functions, you flip them over. And the problem is the square root of 2 on the bottom. So you multiply top and bottom, you rationalize by square root of 2. So when you multiply top and bottom by square root of 2, you end up with 11 square root of 2, and at the bottom, square root of 2 times the square root of 2 is the square root of 4. And square root of 4 is just 2. So 6 times 2, it's 12. So cosecant, it's 11 square root of 2 over 12.
Okay, that does better different.
Okay. Now,
Miss,
okay,
so if it's 6 over the square root of 2, you don't worry about the 6?
6 over the square root of 2, no, the 6 is okay on top.
Okay, so there where he did 11 over 6 square root of 2, he multiplied square root of 2 square root of 2.
Yes, you rationalize. So it would
Put
be,
on the calculator.
you don't do calculators.
Oh.
No, this is just, you leave it in simplest radical form.
So 2 times 2 is 4, obviously. and
Yes,
6
the
times
square root of 4 is 2, and 2
okay.
times 6
Yeah,
is
'cause I was
4.
doing it on the calculator, so that's
Okay.
why I was getting
So on the homework, just do the first part, which is numbers 1 through 8. 1 through 8 only, okay? Have a wonderful day, guys.
Do you need to see more?